Microsoft is currently executing a total commitment of 25.8 billion rand to expand its cloud and artificial intelligence infrastructure across South Africa. That total includes a recently confirmed 5.4 billion rand expansion, intended to scale operations in Johannesburg and Cape Town by 2027. Building on these two established locations strengthens South Africa's position as Africa's leading cloud computing hub, attracting further digital investment to the region. This is more than a corporate announcement. It is a permanent physical footprint on the geography of these cities, a digital commitment that must be physically sustained by the land it occupies. We often perceive the cloud and artificial intelligence as invisible, weightless pieces of software that exist in a digital vacuum. In reality, AI workloads live inside hyperscale data centers. These are sprawling industrial facilities packed with thousands of servers processing calculations at massive scale. Because of this density, hyperscale facilities are among the most resource-intensive industrial sites being developed globally. This raises a critical question for South Africa. Can the country's foundational electricity and water grids support the immense requirements of these facilities? The local race for AI dominance now depends entirely on the capacity and reliability of traditional municipal infrastructure. Keeping these servers running requires an uninterrupted flow of electricity at a scale far beyond typical industrial use. Reliable power access has become the primary strategic advantage that determines where technology companies deploy their next generation of AI infrastructure. To meet this demand, Eskom is investing in transmission infrastructure to improve the environment for energy-intensive industries. We are also seeing a surge in private sector renewable energy generation and battery storage projects designed to provide stable, independent power. These renewable projects allow global tech companies to meet their commitments to carbon-neutral operations while drawing from the local grid. A modern tech hub is only as viable as its underlying high-voltage transmission networks and green energy supply. As these processors draw electricity, they generate a blistering amount of heat that must be constantly managed to keep the hardware from failing. Most facilities rely on sophisticated water-based cooling systems, making reliable access to water infrastructure just as critical as the electrical grid. This has become a global pressure point. In parts of the United States, planning for large-scale AI data centers is now dictated by the availability of municipal water. For South Africa, this creates a push toward wastewater recycling, smart industrial management, and closed-loop systems to ensure long-term water resilience. Without sustainable water management, a multi-billion rand data center cannot function. Meeting the needs of these sites triggers a mobilization across the entire industrial supply chain. Construction requires a massive scale of civil engineering, heavy construction, and the development of specialized electrical substations. Then there is the digital plumbing, thousands of miles of high-capacity fiber optic networks required to link these hubs to the rest of the world. These facilities also demand ongoing, specialized maintenance and high-level physical security to protect the hardware long-term. This 25.8 billion rand commitment functions as a massive, multi-sector stimulus package for the local physical economy. Microsoft's continued investment reflects global confidence in the growth of South Africa's digital economy. However, maintaining this growth requires municipalities to integrate digital requirements into long-term industrial planning. City planners can no longer treat water, power, and tech zoning as separate issues. They are now completely interdependent. If infrastructure delivery does not evolve at the same pace as digital demand, future technology investment will eventually stall. Winning the global AI race depends on laying concrete and erecting turbines just as much as it depends on writing code. In the age of hyperscale computing, building the future of software requires mastering the heavy industries of the physical world.